In the spring of 1945, American soldiers weren't just liberating Europe. They were racing against time and against each other to steal the most dangerous aviation secrets in human history. Some of what they found defied belief. Jet engines producing thrust figures American engineers hadn't dreamed of. Swept-wing designs that wouldn't appear in American textbooks for another decade. Aircraft so advanced that capturing them became, in some cases, a higher military priority than the towns surrounding them. The Germans had been building the future, and in the final weeks of the war, the Allies took it. To understand what Operation Paperclip really was and what it recovered, you have to go back to 1933, the year Adolf Hitler came to power, and the year Germany's aviation industry began its quiet, extraordinary transformation. The Treaty of Versailles had forbidden Germany from building military aircraft. So German engineers spent the interwar years doing something arguably more valuable. Thinking, theorizing. Solving problems in aerodynamics, propulsion, and materials that the Allied powers. Comfortable in their conventional propeller-driven assumptions, barely recognized as problems yet. By the late 1930s, Germany had an aviation research infrastructure unlike anything else on Earth. The Deutsche Exanstalt, Far Luftfahrt, the German aviation research establishment, was producing wind tunnel data that Allied analysts would later describe as years ahead of anything they had seen. Hermann Göring's Luftwaffe poured funding into experimental programs with a recklessness that, in peacetime, would have seemed irresponsible. In wartime, it produced miracles. Then, as Germany began losing the war, the pace accelerated. Desperation is a remarkable engineering catalyst. By 1944, Germany was fielding operational jet aircraft, the Messerschmitt Me-262, while simultaneously developing rocket-powered interceptors, flying wing bombers, and supersonic research aircraft that would not be replicated in the West for years. When Allied intelligence began piecing together the full scope of what the Luftwaffe had been building in secret, the reaction was not triumph, it was alarm. The order came down quietly but urgently. Find the engineers, find the aircraft, find the documents before the Soviets do. What followed was one of the most consequential intelligence operations in aviation history. Title: Project Paperclip. The classified jets we stole from Hitler in the spring of 1945. American soldiers weren't just liberating Europe. They were racing against time and against each other to steal the most dangerous aviation secrets in human history. Some of what they found defied belief. Jet engines producing thrust figures American engineers hadn't dreamed of. Swept-wing designs that wouldn't appear in American textbooks for another decade. Aircraft so advanced that capturing them became, in some cases, a higher military priority than the town surrounding them. The Germans had been building the future. And in the final weeks of the war, the Allies took it. To understand what Operation Paperclip really was and what it recovered, you have to go back to 1933, the year Adolf Hitler came to power and the year Germany's aviation industry began its quiet, extraordinary transformation. The Treaty of Versailles had forbidden Germany from building military aircraft. So German engineers spent the interwar years doing something arguably more valuable. Thinking, theorizing. Solving problems in aerodynamics, propulsion, and materials that the Allied powers. Comfortable in their conventional propeller-driven assumptions, barely recognized as problems yet. By the late 1930s, Germany had an aviation research infrastructure unlike anything else on Earth. The Deutsche Exanstalt Far Luftfahrt, the German aviation research establishment, was producing wind tunnel data that Allied analysts would later describe as years ahead of anything they had seen. Hermann Göring's Luftwaffe poured funding into experimental programs with a recklessness that, in peacetime, would have seemed irresponsible. In wartime, it produced miracles. Then, as Germany began losing the war, the pace accelerated. Desperation is a remarkable engineering catalyst. By 1944, Germany was fielding operational jet aircraft, the Messerschmitt Me-262, while simultaneously developing rocket-powered interceptors, flying wing bombers, and supersonic research aircraft that would not be replicated in the West for years. When Allied intelligence began piecing together the full scope of what the Luftwaffe had been building in secret, the reaction was not triumph. It was alarm. The order came down quietly but urgently. Find the engineers, find the aircraft, find the documents before the Soviets do. What followed was one of the most consequential intelligence operations in aviation history. The man most responsible for Germany's jet age was not a general or a politician. He was a quiet, meticulous engineer from Bamberg named Hans von Ohain, while Frank Whittle in Britain was independently developing jet propulsion along parallel lines. Von Ohain had secured the interest of Ernst Heinkel, one of Germany's most ambitious aircraft manufacturers, and by August 27, 1939, 3 days before Germany invaded Poland, the Heinkel He-178 made its first flight. It was the world's first turbojet-powered aircraft to fly. The Allies knew nothing about it. That secrecy was deliberate. Germany understood, from the beginning, that its jet programs represented a decisive asymmetric advantage, one worth protecting at nearly any cost. Test facilities were moved inland away from coastal reconnaissance routes. Development work on the most sensitive programs was dispersed across multiple sites. Engineers were given cover stories, and certain programs were compartmentalized so tightly that even senior Luftwaffe officers didn't know their full scope. The Me-262 is the aircraft most people know, and for good reason. Designed by a team led by Waldemar Voigt at Messerschmitt's facilities in Augsburg and later Regensburg, it was the world's first operational jet fighter. Powered by two Junkers Jumo 004B axial flow turbojet engines producing approximately 1,980 pounds of thrust each. It could reach speeds of around 540 miles per hour, roughly 100 miles per hour faster than the fastest Allied piston engine fighters it faced. The first prototype, the Me-262V1, flew under piston power in April 1941 because the Jumo engines weren't ready. It flew on jets for the first time on July 18, 1942, piloted by Fritz Wendel at Leipheim Airfield. Wendel was one of Germany's most experienced test pilots, a man who had set world speed records before the war, and even he was shaken by the sensation of jet-powered acceleration. But what Allied intelligence didn't fully appreciate until they captured German facilities in 1945 was how far beyond the Me-262 German aviation had already gone. In the hills near Nordhausen, underground factories built with concentration camp labor had been producing V-2 rockets. The same tunnels had been planned for jet engine production. When American forces from the 3rd Armored Division reached the Mittelwerk facility in April 1945, they found not just rockets, but an engineering archive of staggering depth. Documents, blueprints, technical manuals, the paper trail of a technological civilization that had been simultaneously fighting a war and designing the next century of flight. Colonel Holger Toftoy, commanding officer of Army Ordnance in Europe, made a rapid and controversial decision. He authorized the removal of approximately 100 V-2 rockets and their associated technical documentation before the area was handed over to Soviet forces per prior Allied agreement. It was technically within the letter of American orders. It was certainly within their intentions, but the rockets were only part of the story. At Lager Lechfeld, near Augsburg, American forces discovered intact Me-262s in various states of completion. At Rechlin, the Luftwaffe's primary flight test center, equivalent to Edwards Air Force Base in function, if not in fame, they found documents describing programs that hadn't even reached prototype stage, including the Heinkel He-162 Volksjäger, a single-engine jet fighter built almost entirely of wood due to aluminum shortages, which had actually entered limited production and combat service in the final weeks of the war. The He-162A2, powered by a single BMW 003E1 turbojet, had a top speed of around 522 miles per hour. It had been designed, built, flown to operational status in less than 90 days, a feat of compressed engineering that left American aviation officials genuinely incredulous. Then there was the Heinkel. He won 62's darker sibling in concept, if not in lineage. The Bacumba 349 Natter. This was not a conventional aircraft in any meaningful sense. It was a vertical launch, rocket-powered interceptor designed to be flown by minimally trained pilots, essentially a guided missile with a man inside. Powered by a Walter HWK 509C rocket motor and 4 solid-fuel Schmidding rockets for launch assist. It was designed to be fired vertically from a launch rail, fly into an Allied bomber formation at speeds exceeding 500 miles per hour, fire its nose-mounted rockets, and then allow the pilot to bail out while the aircraft's nose section containing the engine was recovered by parachute for reuse. The pilot's survival was considered not guaranteed. The only manned test flight of the BA 349 occurred on February 28, 1945, at Heuberg Test Site in Baden-Württemberg. The pilot was Lothar Sieber, a young Luftwaffe test pilot. The flight lasted approximately 1 minute. The canopy detached shortly after launch, almost certainly incapacitating Sieber. The aircraft climbed to altitude, then dove into the ground. Sieber was killed. He was 22 years old. He is likely the first person to have died in a vertical rocket launch of a manned aircraft. The program was abandoned. When American forces found the remaining BA 349 airframes in a barn near the test site in April 1945, they quietly shipped several to the United States for evaluation. The Horten Ho 229 was something else entirely. Designed by brothers Reimar and Walter Horten. Aircraft designers who had been obsessed with flying wing configurations since the 1930s. The Ho 229 was a twin-jet flying wing intended to fulfill Gring's so-called 3x1000 requirement. An aircraft capable of carrying 1,000 kilograms of bombs at 1,000 kilometers per hour with a range of 1,000 kilometers. The V-2 prototype, powered by 2 Junkers Jumo 004B engines, flew for the first time in February 1945 at Oranienburg Airfield, piloted by Erwin Ziller. Early flight reports described remarkable handling and speed. Then, on February 18, 1945, Ziller took the V-2 up again. One engine flamed out. Ziller attempted to manage the asymmetric thrust. He couldn't. The aircraft crashed. Ziller died. He was the only pilot to have flown the jet-powered Ho 229, and he took whatever first-hand impressions he had of it into the ground with him. The sole surviving Ho 229 V3, which had been in various stages of construction at the Gotha factory, when American forces arrived, was transported to the United States, where it eventually ended up at the Smithsonian's Paul E. Garber facility in Suitland, Maryland, where it remains today, unrestored, deeply studied, and still provocative. Decades later, Northrop Grumman conducted radar cross-section tests on a replica and found that the flying wing's geometry and the charcoal mixed into its plywood skin may have had some degree of radar-absorbing properties, though historians and engineers continue to debate how intentional that was, and how significant it would have been against 1940s radar systems. What can be said without serious dispute is that the Horten brothers were building something genuinely different from anything else in the air in 1945. Operation Paperclip, formally authorized in September 1945 by the Joint Intelligence Objectives Agency, brought over 1,600 German scientists, engineers, and technical specialists to the United States under contracts with American military and research institutions. Werner von Braun, who had overseen V-2 development at Peenemünde, eventually led NASA's Marshall Space Flight Center and served as chief architect of the Saturn V rocket that carried American astronauts to the moon. Hans von Ohain, the man who had first flown a jet aircraft in 1939, ended up at the Air Force Wright-Patterson facility in Ohio, where he eventually served as chief scientist of the Aero Propulsion Laboratory. He and Frank Whittle, his British parallel, became friends in later life. Two men who had independently arrived at the same world-changing idea on opposite sides of a catastrophic war. The aircraft and documents captured in 1945 flowed directly into the American and British post-war aviation programs. The swept-wing data from German aerodynamicist Adolf Bismann's work, which he had presented openly at an international conference in 1935, but which almost no one outside Germany had taken seriously, was found in captured archives and immediately influenced the design of the North American F-86. Sabre, the Jumo 004 and BMW 003 engines were studied intensively. German research into ejection seats, pressurized cockpits, and high-altitude flight medicine informed Allied aviation medicine programs for years. The Soviets did not come away empty-handed. They captured the Junkers and BMW engine factories in their occupation zone. They brought back German engineers through their own program, sometimes with considerably less voluntary participation than the American approach nominally required. The MiG-15, which American pilots would face over Korea just 5 years later, flew on an engine derived in significant part from the Rolls-Royce Nene, which Britain, in a decision that generated considerable controversy, had licensed to the Soviet Union, but its airframe owed recognizable debts to German swept-wing research. The war had ended. The technology had not stopped moving. What Paperclip represented beyond the ethical complications that historians have rightly raised about employing men who had, in some cases, direct knowledge of or involvement with forced labor programs, was the recognition that the Second World War had produced a technological rupture. The aircraft that fought at the Battle of Britain in 1940 were evolutionary descendants of the biplanes of the First World War. The aircraft emerging from German drawing boards in 1945 were ancestors of the fighters that would define the Cold War. The gap between those two worlds had been crossed in 5 years of desperate, violent, extraordinary engineering. The men who crossed it were not all heroes. Some were complicit in atrocities. The moral accounting of Paperclip remains unfinished and should remain contested. But the technology they carried, the swept wings, the axial flow turbojets, the boundary layer research, the rocket propulsion data reshaped aviation permanently. In a sense, every time a commercial jet lifts off from a modern runway, carries a faint, complicated inheritance from those secret facilities in Bavaria and Thuringia, from those underground tunnels at Nordhausen, from those wind tunnels at Göttingen, where the supersonic future was first glimpsed. The jets they built to win a war we use to cross oceans. That is perhaps the strangest, most enduring consequence of what America stole from Hitler's engineers in the spring of 1945.